Hi everyone! Today, we're diving into a common head-scratcher in LTspice simulations. We'll be looking at the LM311 comparator. Specifically, we're building a circuit with hysteresis. You know, to get that clean, snap action switching. But sometimes, it just doesn't behave as expected. You set it up, run the simulation, and instead of crisp transitions, you get something weird. Maybe it oscillates rapidly. Perhaps it never switches at all. Or the voltage thresholds are completely off from your calculations. It's incredibly frustrating, right? Let's break down what might be going wrong with your LM311 hysteresis circuit in LTspice. First, let's talk about the LM311 itself. It's a fantastic, versatile comparator. But it has a crucial characteristic, an open collector output. This means its output can only actively pull low, or sink current. To go high, it needs an external pull-up resistor. This resistor connects from the output pin to a positive supply voltage. If you forget this resistor, your output will likely float high, or stay low, or just act erratically in the simulation. This is a very common oversight. Always check for that pull-up resistor in your LM311 circuit. Next, consider your power supplies. Are they correctly connected? The LM311 can operate with single or dual supplies. Ensure your VCC and VEE, or ground, connections are solid and stable. Also, check your common mode input range. The input voltage to the comparator, both inverting and non-inverting, must stay within a certain valid range relative to your supply rails. If your input signal goes outside this range, the comparator won't work correctly. It might saturate or simply not respond to changes. Then, there's the hysteresis network itself. Double-check your resistor values. The positive feedback creates two distinct switching thresholds, an upper threshold, V_upper, and a lower threshold, V_lower. Make sure your calculations for these thresholds match what you expect. A small error in resistance can lead to wildly different switching points in your simulation. Sometimes, the issue isn't the circuit, but the simulation settings. Is your transient analysis step size appropriate? If it's too large, the simulator might miss fast transitions or rapid oscillations. Try making the time step smaller for more detail. Also, ensure your simulation duration is long enough to see the full behavior of your circuit, including multiple cycles of your input signal. Initial conditions can also play a role. Sometimes, forcing an initial state can help the simulator settle into the correct operating mode. Another point to consider is the LM311 model itself within LTspice. While generally accurate, some generic models might not capture all nuances perfectly. If you're using a basic model, sometimes finding a more specific one can help. Output loading also matters. Even with a pull-up, if you're trying to drive too much current into a low impedance load, the output might struggle to reach its intended high voltage. So, if your LM311 hysteresis circuit in LTspice is misbehaving, start with these checks. Look at that pull-up resistor first. Verify your power supplies and input common mode range. Recalculate your hysteresis thresholds. Adjust your simulation settings. Often, the solution is simpler than you think. A missing pull-up resistor or an out-of-range input signal can cause all sorts of unexpected and confusing behavior. Thanks for watching. I hope this helps you troubleshoot your LTspice simulations. If you found this useful, please hit that like button. And don't forget to subscribe for more electronics tips and LTspice tutorials. See you next time.